Hi and welcome back. So let's talk about hashing and equality, and let's review that pretty quickly. Now I know I haven't talked about inheritance yet, but there is kind of an object class that every class inherits from. And it's called the object class. And we can take a look at some of the functionality in that object class. And as you can see, it has things, for example, like the dunder EQ method. It also has things, for example, like the wrapper method. So it has a default implementation for that. It has a default implementation for the hash method as well, and a few other things too. So we always get that functionality for free, which means that when we create a class, like let's say the class person, and I'm not going to implement anything in my class, but of course we can still make an instance of the class. And so I'll make two different instances of that class, P1 and P2. They are both hashable. They have a hash. And the way that Python calculates the hash, it basically uses the identity, the memory address, right, the ID of P1 and P2 to calculate a hash value. And of course, it also implements the equality. And again, how does it implement equality? By essentially looking at the memory address as well. So what happens is that if we think about the relationship between equality and hash, then if two objects are equal, they will have the same hash. And that's true in this case because P1 is equal to P2 if they have the same memory address, and therefore their hash will be the same. Okay, that's one of the prerequisites for hash functions. Two objects that are considered equal must have the same hash. Now we can override this dunder equals method. Let's go ahead and do that. So let's say class person, and we're going to create an init so we can put in some values, and we're just going to have a name. Okay, so that's going to define our name attribute, and then I'm going to define the equals self and other, and I'm going to return here is instance other comma person. So first of all, is it a person? And if it is, are the names equal to each other in terms of values? And then we could also add a representation here. So let's go ahead and do that. Wrapper self, and I'm just going to return an F string. We'll say this was a person and it was created with name equal to, and then we'll interpolate self.name. Okay, so now we have these two person objects. We have this person class, and let's create some person objects. Let's create person John for P1. P2, I'm going to create another person with the same name. So in terms of my equality, I would consider these two people to be the same people. They have the same name, they're the same persons. And then I'm going to create a third person. Let's call that one Eric. So that one definitely is not the same. So P1 equals to P2, that is now true, because it's using the name comparison, right? Both are person objects and they have the same name. On the other hand, P1 equal to P3 is false because they don't have the same name. But we've lost hashing. If we try and hash P1, you'll see we get an exception. We get this unhashable type. And why does Python do that, right? Because by default, it does implement the hash. Here, it takes it away basically. As soon as we define the equals method, Python takes away its hash implementation. Why? Well, if you think about how it was implementing the hash, it was implementing it based on the ID. So if it kept that default implementation, then the hash of P1 and P2 would not be the same because they're two different objects. And yet I'm saying that they're actually equal because I'm comparing them based on the name. So here I have P1 and P2 that are equal to each other but would not have the same hash. That, of course, is not possible. That doesn't work. So in order for us to rectify this, we now have to create our own hash implementation in our class. Now, why do we want objects to be hashable? Simply so we can use them in dictionaries. For example, we cannot now make P1, John Cleese, let's say. We cannot make P1 a key in our dictionary because it is not hashable. So in many instances, we want things to be hashable so that we can put them into dictionaries or sets. So if we look at the P1 hash, right, if we look at the hash attribute of P1 right now, we get nothing. And of course, that just means that the representation, right, of the none type. So basically, as soon as we define equals, Python sets the hash to none. And this is how we do that in our own classes. If we want to explicitly specify that they're not hashable, we can just set the hash class attribute to none. That will have the same effect. So now, however, we want to provide our own override for the hash function so that our object becomes hashable. Now, what's important to remember is that in dictionaries, we really want our keys to be immutable. Since I'm using name for equality, I'm also going to base my hash on name, and I'm also going to want to make name immutable. So let's go ahead and fix everything up here, and let's copy paste and start making those implementations. So first, I'm going to implement the hash method. So let's go ahead and implement the hash. And I am basically just going to return the hash of self.name. Okay? So that's how my hash is going to work. So now I can go ahead and create instances of my person property. The only thing still though that bothers me here is that name, is mutable. Somebody can create an instance of person and just modify the name. And I don't want that to happen. Now I can't stop them, but I can discourage it by using a read-only property and a pseudo-private variable. So that's what I'm going to do here. I'm going to use a pseudo-private variable for name. And you'll notice I don't have to change any of the other code here. My interface to my class is going to stay the same because I'm going to make name a property. So it's going to be a property, and that's just going to return self._name. So now I have an immutable class with respect to name. Now, what does it mean for the class to be immutable in terms of hashing it and putting it into a dictionary? The only portion of the class that we want to be immutable is the portion that's used for the equality and the portion that's used for the hash, because we want that to be used as the hash function for the keys in our dictionary types. So we want those parts to be immutable. Anything else in the class, maybe we have an age, a date of birth, a bank account balance, that's fine. That can be mutated. That doesn't affect the hash of the class and the equality of the class, right? Or the equality of the objects and the hash of the objects that are instances of this class. So now that we have this implementation, things kind of come back to normal, or at least what we might think as being normal. So we can create this person Eric. We have a hash now for that, and if P2 is equal to person Eric, you'll see that P1 is equal to P2 is true, and the hash of P1 and the hash of P2 are equal as well, because P1 is equal to P2 means that the hash should be the same as well. And so now we can create a dictionary that contains this object as a key, right? So we could say Eric, and now that works just fine. You can see we have this person as this person object as a key in our dictionary. And of course we can use it in a set as well. We can say set P1, right? And now that set contains that person. Again, we can only put hashable elements into sets and keys of dictionaries. All right, so thanks for watching, and I'll see you in the next video.